Welcome to the Podlets podcast.
Hi, everyone. Welcome back to the Kubernetes show, episode 4. Today, we're going to talk about observability. I am Carlise Campos. Today, here on the show with me are Duffy Cooley.
How you doing, folks? I'm Duffy Cooley. I'm staff field engineer here at VMware, and I'm looking forward to this topic. Also
with us is Chris Nova.
Hey everyone, I'm Chris Nova. I don't know, what do I do? I'm a developer advocate. I code a lot. I hang out in Kubernetes. I don't know.
Well, I don't want to be left out. I'm an engineer in the open source project called Valero that does backup and recovery for your Kubernetes applications. So what's going on? Observability. Why do we care?
Oh, that's the $1 million question right there, honestly.
It sure is.
I don't know. I have a lot of thoughts on observability. I feel like it's one of those words that it's kind of like DevOps. Like, it depends which day of the week you ask a specific person what observability means, and you'll get a different answer.
Yeah, I agree with that. It seems like it's one of those very hot topics. I mean, it feels like people often conflate the idea of monitoring and logging of an application with the idea of observability and what that means. So I'm looking forward to kind of digging into the details of that.
What does observability mean to you, Duffy?
So in my take, observability is a set of tools that can be applied to describe the way that data moves through a distributed system, whether that data is a particular request or a particular transaction. In this way, you can actually understand the way all of these distributed parts of this system that we're building are actually interacting. And as you can imagine, things like monitoring and metrics are a part of it, right? Like being able to actually understand how the code is operating for this particular piece of the system is definitely a key part of understanding how that system is operating. But when we think of it as a big distributed system with terrible network daemons in between and lots of other kind of stuff in between, I feel like we need kind of a higher level of context for what's actually happening between all those things. And that's where I feel like the term observability fits.
Yeah. I think I generally agree with that. I've got a few nuances that I like to pick out, but I have high opinions. But yeah, I mean, I hear a lot about it. I have my own ideas of what it means, but like, why do we need it?
I want to hear your ideas of what it is. What is it? How would you define it?
I mean, we have an hour to listen to me rant about observability. I mean, basically, like, okay, so I'm an infrastructure engineer. I wrote this book, Cloud Native Infrastructure. Everything to me is some layer of software running on top of the infrastructure. And observability to me is, it solves this problem of how do I gain visibility into something that I want to learn more about. Like, I think my favorite analogy for observability, have y'all ever been to like a gas station or a convenience store? And on the front door, there's it's like a height scale chart. It'll say like 4 feet, 5 feet, 6 feet, 7 feet. I always wondered what that was for. And I remember I went home one day and I Googled it, and it turns out that's actually for if the place ever gets robbed. As the person runs out the front door, you get a free height measurement of how tall they are so you can help identify them later. To me, that's like the perfect description of observability. It's like cleverly sneaking things into your system that can help you with a problem later downstream.
I like that.
Yeah.
So observability is sort of a new term because it's not necessarily something that I, as a developer, would jump in and say, oh, gee, my project doesn't do observability. I need it. I understand metrics and I understand logging, monitoring. And so now I hear of observability. Of course, I read about it to talk about it on the show. And it's not the first, and I have been running into this word everywhere. But I feel why are people talking about observability? That's my question.
Yeah. Well, I think this kind of goes back to the gas station analogy again, right? Like, what do you do when your metaphorical application gets robbed. Like, what happens in the case of a catastrophic problem, and how do you go about preparing yourself the best way possible to have an upper hand at solving that problem?
Yeah.
Right? Like, some guy robbed a store and then ran out the front door, and then we realized, oh, we have no idea how tall he is. He could be 4 feet tall, or he could be 6 feet tall. And then, we learned the hard way that maybe we should start putting markers on the door. I feel like observability is the same thing, but I feel like people just kind of wake up and say, like, I need observability. I'm going to go and I need all of this, like, bells and whistles because my application, of course, is going to break. And I feel like in a weird way, that's almost a cop-out. Like, we should be working on hardening our application before we work on preparing for catastrophic failure.
But why didn't I hear the word observability 10 years ago or even 5 years ago? I think I started hearing it about 2 years ago.
I'll argue that like the term observability is coming up more frequently and is certainly a hot topic today because of effectively context. It still comes back down to context. When you're in a situation where your application, when you've built like a cloud native architecture of your application, you got a bunch of different services that are intercommunicating or maybe all communicating with some particular shared resource, and things are misbehaving, you're going to need to have the context to be able to understand how it's breaking, or at what point it's breaking, or where in the tangled web that we wove is the problem actually occurring, and can we measure that at that point, right? Like, and so traditionally, like in a monolithic architecture, you're not really looking at that. You're like, maybe you break up the monolith, you break up the monolith, you set up a couple set points. You're looking for the way particular code paths work, or if you're on top of the game, you might like instrument your code in such a way that it will emit events when particular transactions happen or particular things happen. And you're going to be looking at those events, and you're going to be looking at logs, and you're going to be looking at metrics to figure out how this one application is performing or behaving. With observability, we have to solve that problem across many systems.
So that is why I put on the show notes that it has to do something with the idea of cattle versus pets. Because I'm saying this because Duffy was asking me before we started recording, why was that on the show notes? And because, correct me if I'm wrong, I think you were going in the direction of saying you don't see the relation, but the relation that I was thinking about was exactly what you just said. If I have a monolith, I'm looking at one thing, maybe I'm looking at one log, I can treat that as my little pet, as opposed to when I have many microservices interacting, I can't even treat anything. If I treated them as pet, they will all die, right? Because I can't, it's just too much. So the idea of reason why observability is necessary sounds to me like that is a problem of scale and complexity.
Yeah, and I think that explains why we're just now hearing it too, right? Like, I'm trying to think of another metaphor here. I guess today's going to be a metaphor day for me. Oh, got it. Okay, so I just got back from London last week. I had gotten off the tube, and I remember I like came up to the surface, and like the blinding light is in my eyes, and all of a sudden I saw a sign for Scotland Yard, and I was like, whoa, I remember this from like all the detective sleuth like stories of my childhood. And it dawned on me that the entire point of this part of London was there to help people recover from disasters. And then I thought about why we don't have Scotland Yard type places anymore. And it's because we have security systems, and we have like different things in place that we had to kind of learn the hard way we needed. And we had to develop technology to help make that easier for us. And I feel like we're just kind of at that cusp of like our first wave of security cameras, metaphorical security cameras with observability. We're at that first wave of we can instrument our code, and we can start building our systems out with this idea of I want to be able to view it or observe it over time in the case of trying to learn more about it or debugging a problem.
So yeah. How do people handle, and I'm asking these questions because truly I have yet to do like to have this problem for my project that I need to do observability in my project, or I need to make sure my project is observable. I mean, other than the bread and butter metrics and logging, that's what we do at Valero. We don't do anything further than that. But I don't know if those two things are what constitute observability. But to what Nova just said, my question is, Well, we want to look at this stuff later, but we're also talking about cattle and these things. Supposedly, your servers are ephemeral. They can go away and come back, go away and come back. How do we observe things if they have gone away?
Yeah. And that's
Yeah.
where we get into like this exciting world of like, how long do we persist our data, and which data do we track? And there's, a lot of schools of thought and a lot of different opinions around what the right solution here is. But I think it kind of just boils down to every application and set of concerns is going to be unique, and you're just going to have to give it some thought.
Should we talk more about that? Because that sounds very interesting.
Yeah. I guess like we should probably just start off with like, given a simple application, concretely, what does it mean to build out quote unquote observability for that application?
Mm-hmm. There's this idea of in a book called Distributed Systems Observability by Cindy Sridharan. I'm probably slaughtering her name, but she wrote that there's like these three pillars, and the three pillars are events, metrics, and traceability or tracing. Events, metrics, and tracing. These are the three pillars of observability. So if we were going to lay out the way that those things might apply to just any old application, like a monolith, then we might look at how that process.
Can we just use like a WordPress blog? Just like for an example, it's got a data store, sure. It's got a thin layer of software and an API.
Sure. So like a WordPress app. So like the first thing we might try to do is actually like figure out what events we would want to get from the application, and figure out how to instrument our application such that we're getting useful data back as far as like the event stream. And so frequently I think that, or in my experience, the way that you want, the things that you want to instrument in your application or any calls that your application is going to make that might represent a period of time, right? Like if it's going to make a call to an external system, that's something that you would definitely want to emit an event for if you're trying to understand, like where the problems are going sideways, like how long it took to actually make a query against the database in the back end of a WordPress blog is a great example, right?
Yeah. So question, you said the word instrumentation. My understanding of instrumentation is like there's kind of a bit of an art to it. And you're actually going in and you're adding like lines of code to your application that on line 13, we say starting transaction. On line 14, we make an HTTPS transaction. And on the next line, we have the event is now over. And we can sort of see that and discover that we made this HTTPS transaction and see where it broke, if it broke at all. Is that, am I thinking about that right?
I think you are. But what's interesting about the reporting on line 14, right, where you're actually saying the event is over, right? I think that we end up actually measuring this in both an event stream and also in a metric, right? So that we can actually understand, of the last 100 transactions to the database, like are we seeing any increase in the amount of time that process takes? Like, are we actually, are we is this something that we can measure with metrics and like, understand like, is this value changing over time? And then from the event perspective, that's where we start tying in things like contextually in this transaction, what happened, right? So in this particular event, is there some way that we can correlate the event with perhaps a trace? And we'll talk a little bit more about tracing too, but like, so that we can understand, okay, well, we have, at 2:00, we see that there is like an incredible amount of latency being introduced when my WordPress blog tries to write to the database, and it happens every day at 2:00. I need to figure out what's happening there. And so like, that's a great, to even get to the point where I understand it's happening at 2:00, I need things like metrics, and I need things like events, specifically give me that time correlation to understand, oh, it's at 2. Yeah.
And this is where we get into what Carlicia just asked about, which was, how do we solve this problem of what do we do when it goes away? Like in the case of our 2 p.m. Database latency, like for lack of a better term, let's just call it the heartbeat, the 2 p.m. heartbeat. What happens when the server that was experiencing that latency mysteriously goes away? Where does that data go? And then you look at tools like, I know Prometheus does this and Elasticsearch has the capability to do this, but you look at how do we start managing time series data and how do we start tracking that and recording it? And it's a fascinating problem because you don't actually record, 2 p.m. to this second and this degree of a second, this thing happened. You record how long it's been since the previous event. So you're just constantly measuring deltas. Like it's like the same way that Git works. Like every time you do a Git commit, you don't actually write all 1,000 lines of software. You just write the one line that changed. Yeah. I
think you highlight both of the two of you highlight a really good point around like this whole cattle versus pets thing. And this is actually something that I spent a little time with in a previous life, and the challenge is that, like, especially in systems like Kubernetes and other systems where you have, perhaps your application is running or being scaled out dynamically or scaled down dynamically based on load. You have all of these ephemeral events. You have all of these events that are from pods or from particular instances of your application that are ephemeral. They're not going to be long-lived. And so this highlights a kind of a new problem that we have to solve, I think, when we start thinking about cloud-native architectures, in that we have to be able to correlate that particular application with information that gives us the context to understand, like, perhaps this was this version of this application, and these events are related to that particular version of the app. And when we made a change, we saw a great reduction in the amount of time it takes to make that database call, and we can correlate those new metrics based on the new version of the app. And because we don't have this like as a long-term entity that we can measure, like this isn't like a single IP in a single piece of software that is not changing. This is any number of instances of our application deployed. Like it makes you have to think about this problem fundamentally differently and how you store that data. And this is where that cardinality problem that you're highlighting comes in.
Yeah. Okay, I have a question. Open question for the group. What is the scope here? And I guess to kind of build on our WordPress analogy, let's say that every day at 2 p.m. we notice there's this latency, and we've been, we spent the last 2 weeks just endlessly digging through our logs and trying to come up with some sort of hypothesis of what's going on here, and we just can't find anything. Everything we've talked about so far has been at the application layer of the stack. Instrumenting our application, debugging our application, making an HTTPS request. What happens, or what should we do, or does observability even care if one of our hard drives is failing every day at 2 p.m. when the cleaning service comes by and accidentally bumps into it or something? How are we going to start learning about these deeper problems that might exist outside of our application layer? Which, in my experience, those are the problems that really stick with you and really cause a lot of trouble.
Yeah, agreed. Or somebody has scheduled a backup of your database every day at 2, so it locks the database for a period of time of the backup, and then you're like, well, wait, when did that happen? Why did that happen? Somebody
commented out a line in the cron tab, and then the server got reset, and there's some magical bash script somewhere on the server that goes and rewrites the cron tab. Mm-hmm. Yeah, who knows?
Yeah, these are the needles in the haystack that we've all stumbled upon one way or another.
So does observability, are we responsible for instrumenting the operating system layer, the hardware layer?
But isn't that what monitoring is? Some sort of testing from the outside, like an external testing that, of course, it gives us the information after the fact, right? But the server already died. My application is already not available, so now I know.
Yeah.
But isn't that what monitoring would? Isn't monitoring what would address a problem like that?
I think it definitely helps. I think what you're digging at, Chris, is correlation, being able to actually identify at a particular period of time what's happening across our infrastructure, not just to our application. Being able to, and the important part is how you even got to that time of day. How do you know that this is happening? When you're looking for those patterns, how did you get to the point where you knew that it was happening at 2 o'clock?
Right.
And if you know that it's happening at 2 o'clock because of the event stream per se, right, that actually gives you a time correlation. Now you can look at, okay, well, now I have a time, and now I need to scoot back to a macro level and see,
and crank it up at 2 p.m.
Yeah, globally at 2 o'clock, what's going on in my world, right? I know that these are the two entities that are responsible. I know that I have a bunch of pods that are running on this cluster. I know that I have a database that may be external to my cluster or maybe on the cluster. I need to really like understand what's happening in the world around those two entities as it correlates to that period of time to give me enough context to even troubleshoot. But
yeah. So I mean,
How do you?
Oh, sorry. Go ahead, Carlicia.
No, how do you do it though? Because I'm still going to go back to the monitoring. I mean, if I'm using an external service to ping my service, and my service is down, I'm going to get the timing. Right, I can go back and look at the information, the log stream. Would I know that it was because of our server? No, but should I be pinging the server too? Should I be pinging every layer of the infrastructure? How do people do that?
Yeah, that's kind of what I was alluding to. Is like where does like observability at the application level stop and systems observability across the entire stack start? And what tools do we have and where are the boundaries there?
Got it. So I think this is actually where we start talking about like that third pillar that we were referring to earlier, which is tracing and the ability to understand from the perspective of a particular transaction across the system what entities that particular transaction will touch and where it spends its time across that entire transaction. So if what I was trying to do was actually submit a comment on a WordPress blog. If I had a way of implementing tracing through that WordPress blog, I might be able to leave myself little breadcrumbs throughout the entire set of systems and understand, okay, well, at what point where in this particular web transaction am I spending time? So I might see that, from the load balancer, I begin my trace ID. And that load balancer terminates to this pod, and inside of that pod, I can see where I'm spending my time. A little bit of time to kind of load the assets and stuff, a little bit of time for pushing my comment to the database, and identifying what that database is an important part of that trace. Like if I understand, I need to know where that traffic is going to go next and how much time I spent in that transaction. So again, this is like down to that code layer. Like we should have some way of actually like leaving us, producing an event that may be related to a particular trace ID, so that we can correlate the entire life cycle of that transaction, that unique trace ID across the entire process.
Interesting.
It helps us narrow the field and understand what all the bits are that are actually being touched, that are part of the problem. Otherwise, we're looking at the whole world, and like obviously that's a much bigger haystack, right?
Right. So one of the things that I've kind of learned about Kubernetes is, as I've been like working with Kubernetes and explaining it to people and going out on the road and talking and doing public speaking, I found that it's very easy for users to understand Kubernetes if you break it down into three things: compute, network, and storage. And what I'm kind of getting at here is like the application layer is probably going to be more relevant to the compute layer. Storage is going to be that's observability. Storage is going to be more monitoring. That's going to be, what is my system doing? Where am I storing my data? And then network is kind of related to tracing, which we're looking at here. And these aren't like necessarily one-to-one, but it just kind of had like distribution of concerns here. Am I thinking about that like kind of the same way you are, Duffy?
I think you are. I think what I'm trying to get to is like, I'm trying to identify the tools that I need to be able to understand what's happening at 2:00 and all of the players involved in that, right? And
Okay.
So for that, I'm actually relying on tools that are pretty normal, like the ability to actually monitor all the systems and understand what's, and have like real timestamp stuff that describes, like I got a Nagios alert or what have you that says that, my backup for the MySQL databases started at 2:00 and that it ends at 2:30. I'm relying on things like an event stream to say, give me some context of time, like when my problem is happening. And I'm relying on things like tracing, perhaps, just to narrow the field so that I can actually understand what's happening with this particular transaction and what are the systems that I should be looking at, whether that is there's a bunch of time being spent on the network. So what's going on with the network at 2:00? There's a bunch of times being spent on persisting data to a database. What's going on with the database? And this kind of gives me, I think, enough context to actually get into troubleshooting mode, right?
Yeah. And I don't want to like take away from this lovely definition you just dropped on us, but I'm going to take a stab at trying to summarize this. So observability, it spans the whole stack. So I mean, it's like if you look at the OSI reference model, it's going to cover every one of those layers, and all it really is it's just a fancy word for all the tools to help us solve a problem. Yeah. Sorry, I'm not trying to like take away from your definition.
No, you're right.
But I kind of want to just like simplify it so that like I can grok it a little bit better.
How about people? Does culture factor into it, or is it just tools?
I think culture is a huge part of it. Pesky human.
Would this culture be tremendously different from what we get now usually, at least with modern teams, modern companies that are doing modern software? That's what I meant to say.
I mean, I definitely think
would it look different?
Yeah, I definitely think there's like, you can always tell. Like somebody once asked, what's the difference between an SRE and a senior SRE? And they were like, patience. And it's like you can always tell folks who've been burned because they take this stuff extremely seriously. And I think that culture, like, there's commodity there. Like people are willing to pay for it if you can actually do a good job at going from chaotic problem, I have no idea what's going on, and making sense of that noise and coming up with a concrete, tangible output that humans can take action on. I mean, that's huge.
Yeah, it is. I was recently discussing the ability in another medium. We were having a conversation around doing chaos testing. And I think that this relates. And the interesting thing that came out of that for me was the idea that, I spent a pretty good portion of my career teaching people to troubleshoot, which is kind of weird, like teaching somebody to have an intuition about the way that a system works and giving them a place to even begin to troubleshoot a particularly complex problem, especially as we start building more and more complex systems, is really a weird thing to try and do. And I think that culturally, when you get into when you have embraced technologies like observability and embraced technologies like chaos engineering, I think that culturally you are not only enabling your developers and your operators, your SREs, to experiment and understand how the system breaks at any point, but you're also enabling them to better understand how to troubleshoot and characterize these distributed systems that they're building. So I think that, and if that is a cultural norm within your company, I mean, think about how many miles ahead you are of like the other people in your industry, right? Like you have made it, like through adopting these technologies, you have enabled your engineering teams, whether they be the people who are writing the code, whether they be the people who are operating the code, or the people who are just trying to keep the whole system up or provide you feedback, to experiment and to develop hypotheses around how the system might break at a particular scale and to test that, right? And giving them the tools with which to actually observe this is critical. Like it's amazing. But
yeah, I kind of like in my mind. I'm on my metaphor kick again. I think of like the bank robber movies where they like take dust and blow it into the air, and then all of a sudden you can see the lasers.
Mm-hmm.
Yeah, I'm kind of feeling like that's what's happening here. Is we're kind of chaos testing would just be the practice of intentionally breaking the lasers to make sure our security system works, and observability is the practice of actually doing something to make those lasers visible so we can see what's going on.
Mm-hmm.
Yeah.
So because the two of you spend time with customers, especially maybe Duffy more so than Nova, but definitely I spent zero time. No, I don't. I spent zero. I'm curious to know if someone, let's say an SRE, wants to implement a set of practices that comprise what we are talking about and saying it's observability, but they need to get a buyout from other people. How do you suggest they go about doing that? Because they might know how to do it or be willing to learn, but they might need to get approval, and they need to get buyout, not a buyout, I'm sorry, a buy-in from their managers, from their colleagues. There is a benefit and there is a cost. How will somebody present that? We just talked about, I'm sorry, no, but Duffy just gave us a laundry list of benefits. But how do you articulate that in a way that you prove the cost, those benefits are worth the cost? And what are the costs? What are the trade-offs?
Yeah. I think this is such a great question, because in my career, I've worked at the world's most paranoid software as a service shop, where, everything we did, we baked emergency disaster recovery into it, every layer of everything we did. And I've also worked at shops that are like, no, we ain't got time for that. Hurry up and get your code moved and pushed to production. And I think there's pros and cons to each, but I think, as you look at the value you have in your application, you're going to come up with some sort of way of concretely measuring that, of saying this is an application that brings in $500 a month or whatever. And depending on that cost or how much your application is worth to you is going to depend, I think, on how seriously you take it. For instance, a WordPress blog is going to probably not have the same level of observability concerns that maybe a bank routing system would have. So I think, as your application gets more and more valuable, your need for observability and your need for these tools is going to go up more and more.
I agree. I think that from the perspective of how do you convince maybe an existing engineering culture to make this jump, to introduce these ideas, I think that that's a tricky question, because effectively what you're trying to do is kind of enable that cultural shift that we were talking about before, right? What tools would set up the culture to succeed as they build out these applications and distributed systems that are going to make up, or that are going to comprise the basis of what your product is, right? What tool, and getting to the, coming at that from an SRE perspective, that's a lot of need air cover to be able to actually have that conversation, have those tough conversations with your developers and say, look, this is why we do it that way, and this is something I can help you do, but fundamentally we need to instrument this code in a way that we can actually observe it and to understand how it's actually operating before we can actually open the front doors and let crazy and let the internet in, right? We need to be able to understand how and when the doors fall off. And if we're not working with our developers who are more focused on understanding, does this function do what it says on the box, rather than is this function implemented in a way that might emit events or metrics, right? It's a completely different set of problems from the developer's perspective. I've seen a couple of different implementations of how to implement this within an organization, and one of them is Facebook's idea of product engineering, or I think it's called product engineering or production engineering, one of the two. And so this idea is that you might have somebody who's similar in some ways to an SRE, somebody who understands the infrastructure and understands how to build applications that will reside upon it, and is actually embedded with your developer team to say, before we can legit sign off on this thing, here are the things that this application must have to be able to and wire into to enable us to operate this app, right? So that we can observe it and monitor it and do all the things that we need to do. And the great part about that is that it means that you're teaming with the developer team. You have some engineering piece that is teaming with the developer team and enabling them to understand why these tools are there and what they're for, and really kind of promoting that engagement.
And it's getting to that place. It's an interesting proposition, isn't it? Because as a developer, I see the world moving more and more towards the developer taking ownership of their apps and knowing more of the more layers of the stack. And if I am a developer and I want to incorporate these practices, and I need to convince someone, but IRM developer, or whoever is in charge of monitoring and making sure the system is up and running, right?
Yeah. So
no, wait, I don't want to lose my train of thoughts. So one way to go about quantifying the need for that is to say, well, over the last month, we spent X amount of hours trying to find a bug in production. And that X is like a huge number. So you can bring that number and say, this is how much that number costs in engineering hours. But on the other hand, you don't want to be the one to say that it takes you 100 hours to find one little bug in production, do you?
yeah. I mean, I feel like this is why agile teams are so successful.
By who?
Agile team. Sorry for cutting you off, Carlicia.
No, it's okay.
Okay. Anyway, I was just going to say, I feel like this is why agile teams are so successful, because baked into how you do your work is this implicit way of tracking your time and your progress. So at the end of the day, if you do spend 100 hours like trying to find a bug, it's sort of like that's the team's hours, that's not your hours, and you sort of get this data for free at the end of every sprint.
Yeah.
But your point is, I mean, what you've brought up is actually kind of another cultural piece that I think is a problem. Like, it has to be, I think that frequently we assume there are many, I should say, let me put this differently. I've seen companies wherein the culture is somewhat damning for people who spend a lot of time trying to troubleshoot something that they wrote. And that is a terrible pattern, because it means that the people who are out there writing the code, who are just trying to get across the finish line with the thing that needs to be in production, right, have now this incredible pressure on them to not make a mistake. And that is not okay. We are all here to make mistakes. That's what we do professionally, is make mistakes, and the rest is the gravy. You know what I mean? Like, and
yeah.
So, like, yeah. It makes me nuts that there are organizations that are like that. I feel like we really just what's awesome about this is I see that narrative raising up, within the ecosystem that around cloud native architectures and other things like that. Is that, like, you were hired to do a hard job, and if we come down on you for thinking that that's a hard job, then we're messing up. You're not messing up.
Yeah, absolutely.
Right? Like,
absolutely. Building software is very hard and complex. So if you're not making mistakes, you're either not human or you're not making enough changes. And in today's world, we still have humans making software instead of robots. We're not there yet. But it's a very risky proposition not to be making continuous changes, because you will be left behind.
Yeah. I feel like there's definitely something to be said about empathy for software engineers. Like, it's very easy to be like, oh my gosh, you spent 100 hours looking on this one bug to save $20. How dare you? But it's a lot harder to be like, oh, you poor thing. You had to dig through 100 million lines of somebody else's code in order to find this bug, and it took you 100 hours, and you did all of that just to fix this one little bug. How awesome are you? And I feel like, that's where we get into the team dynamic of, are we like a blame-centric team? Do we try to assign blame to a certain person? Or do we like look at this as a team's responsibility? Like, this is our code, and, poor Carlicia over here had to go dig through this like code that hasn't been touched in 10 years or whatever.
Yeah.
And another, sorry, Tafi, another layer to that is that, in my experience, I have never done anything in software or looked at any codes or brought up any system that, as trivial as the end result was, and especially in relation to the time spent, it has never happened that it wasn't a huge amount of education that I got to reuse in future work. So
yeah, that's true.
Does that make sense?
Yeah. And that's kind of what I was referring to, is around like being able to build up the intuition around how these systems operate, right? Like, if the more time you spend in the trenches working on those things, right? If you are enabled leveraging technologies like observability and chaos engineering to troubleshoot, to come up with a hypothesis about how this will break when this happens, and test it, and view the result and come up with a new hypothesis and continue down that path, you will automatically, by your nature, build a better intuition yourself around how all of these systems operate. Doesn't matter whether it's the application that you're working on or some other application, you're going to be able to build a better intuition for how to understand and characterize systems in general. You'll be a better engineer for distributed systems if you are in a culture that is blameless, that gives you tools to experiment and gives you tools to validate those experiments and come up with new ones.
Yeah.
I'm going to challenge you, and then I'm going to agree with you. So hang on, okay? So we're going to challenge you. So we're saying that observability, which actually boils down to using automated tools to do all this work for us, that we don't have to dig in manually on a case-by-case basis. No? That's wrong?
No, I'm saying observability is a set of tools that you can use to observe the interactions and the interactions and behavior of distributed systems.
Okay, but with automated tools, right?
The automation piece isn't really. Do you want to take this one, Chris?
Yeah, okay. I think they certainly can be automated. I just don't think there's a hard bit of criteria that says everyone needs to be automated. Like, there ain't nothing wrong with SSHing into a server and running a debug script if you're having a really bad day.
Okay.
Yeah.
Okay, but let me go with my theory. Let's just pretend it is, because it will sound better.
Okay.
All right, so let's say, not to exclude the option to do it manually too, if you want, but let's say we have these wonderful tools that can automate a bunch of this work for us, and we get to look at it at a high level. So what I'm thinking is, whereas before, if we didn't have or didn't use those tools, or we are not using those tools, we have to do a lot of that work manually. We have to look at a lot more different places. And you get to I would challenge you that, but hang on, let me finish the whole spiel. I would challenge you that we develop even more intuition that way. So we are decreasing the level of intuition that we develop potentially by using the tools. Now, I'm going to agree with you. It was just a rationale that I had to follow. I agree with you that it definitely helps you develop intuition, but it is a better quality of intuition because now you can hold these different pieces in your head because you're looking at it at this higher level. Because when you need to look at things at piecemeal, at least I am like that. It's like, okay, I can hold this one thing here is big already in my head. And then for me, when I switch context and go look at something else, I forgot what I looked at over there. And it's really hard to keep track and really wasteful it's impossible to keep all of it in our minds, right? And let's say I have to go through the whole debugging process over again. If I don't have notes, it will be like just the first time because I can't possibly remember. I've been in situations of having to debug different systems and okay, now like third time around, I'm taking notes because the fourth time is just going to be so painful. So having tools that lets us look at things at a higher level, I think has the additional benefit of helping us understand the system and hold it together in our heads. Because, okay, we're not going to know little details how things are happening behind the scene, but how useful is that anyway? I'd much rather know how the whole system works together and the points of failure, like I can visualize, right?
So I have a question for everyone. Following up on Carlisia's how she challenged you and then agreed with you. I really want to ask this question because I think Carlisia's answer is going to be different than Duffy's, and I think that's going to say a lot about the different ways that we're thinking about observability here, and it's really fascinating if you think about it. So have either of you worked in a shop before where you had like the guy? that one person who just knew the code base inside and out. He had been around for forever. He was a dinosaur. And whenever something went wrong, you were like, we got to get this guy on the phone. And he like would come in and be like, oh, it's this one line and this one thing that it would take you 6 months to figure out, but let me just fix this really quick. Bam, 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 bam. And production's back online.
Well, the code base guy.
Yeah.
The systems admin guy, like something that is not my app, but the system broke. Get that person who knew could take 1 second to figure out what the problem was.
Have you seen that before though? Like the one person who just has so much tribal knowledge.
Yeah, absolutely.
Yeah. Duffy, what about you?
I have both been that guy and seen that guy.
I have never been that person.
In lots of shops.
Well, what I'm kind of getting at here is I think observability, and I mean this in the nicest way possible to all of our folks at home who are actively playing the role of the guy. I think observability kind of makes that problem go away, right?
I think it normalizes it, to your point. I think that it basically gives you, so like, I think you're onto it. I think I agree with you. But I think that fundamentally what happens is through tooling like chaos engineering, through tooling like observability, you are normalizing what it looks like to have that, to teach anybody to be that person, right? And that's the key takeaway is like, to Carlicia's point, she might actually, Chris and I promise that we will approach some complex distributed systems problem fundamentally differently.
Yeah.
Right. If somebody has a broken Kubernetes cluster, Chris and I are both going to approach that same problem, and we will likely both be able to solve that problem, but we are going to approach it in different ways.
Yeah.
And I think that the benefit of having common tooling with which to experiment and understand and observe the behavior of these distributed systems means that, we can normalize what it looks like to be a developer and have a theory about how the system is breaking or would break, and having some way of actually validating that through the use of observability and perhaps chaos engineering, depending. And that means that we're turning the keys to the castle over. There's no more bus test. You don't have to worry about what happens to me at the end of the day. We all have this common set.
You can go on vacation.
Yeah.
No, but this is the most excellent point. I'm glad you brought it up, Nova, because what both of you said is absolutely true. I mean, give me a better documentation, and I don't need you anymore because I can be self-sufficient.
Exactly.
Yeah. So in a weird way,
to observe like where things went wrong, and again, going back to that, what I said, that more and more developers are having to being asked. I mean, some developers are proactively taking ownership, and in other cases, they've been asked to take more ownership of the whole stack. And I'm saying, from the application level down the stack. But you give me tools to observe where things went wrong beyond my code as a developer. I'm not going to call the guy.
Yeah.
So the level of self-sufficiency.
The guy doesn't want you to call him.
No.
So it provides an additional benefit that we could say is provide the engineer an additional level of self-sufficiency.
Yeah. Teach someone to fish, give someone a fish.
Yeah.
Yeah.
Exactly. All right. Well, that was a great conversation on observability, and we kind of talked about just a bunch of different topics. This is Duffy, and I had a great time in this session, and thanks.
I was super glad to be here today. Thanks for listening. Come back next week.
Thanks for joining, everyone. And I apologize again to all of our guys at home listening. Hopefully we can help you with observability along the way to get everybody's job a little bit easier.
And I want to say, for the girls, we know that you're out there too. That was really just a joke.
Oh yeah, I was totally
yeah
for a while. Good show, everyone.
Cheers.
Cheers.